Yes, friends. This is B Oza, meeting you again for one more video tutorial class. We are going through short video tutorial classes to understand power system and power system protection. Right now, we are passing through the possible experiments that can be designed in the laboratories of the engineering institutes. And that too, it can be designed at a very low cost so that it would not be difficult for them financially. And the very heavy learning outcome, very good learning outcome is there of all these experiments. And we have been talking about all these things theoretically, but unless we see by our own eyes, we don't believe. So that we can see the things by our own eyes, we can see the things. Everybody is knowing that all high voltage lines like 66 kV, 132 kV, 220 kV, 400 kV, 765 kV, all transmission line conductors are suspended over the transmission towers by suspension type insulators. They are just suspending. There is a reason behind it. There is a reason behind suspension. That the wires are being suspended and wires have a weight. And then there are winds also. So because of wind, the total pressure of horizontal wind and the vertical weight will be slant. And that stresses the parts of the insulating material. Right? That stresses the insulation inside. And it will be, some part will be under tension. And you are all knowing that porcelain, the material that is used for insulator, is very weak at tension. And so that it cannot break, we keep it suspended so that automatically it adjusts itself in such a way that it adjusts itself for the least tension. And therefore they are suspended. Now, how this suspension is done, that also you might all be knowing that we are using a disc of suspension insulator, a single disc. Usually one disc can withstand 11 kV. Now, like that, many discs are connected in series, and the connection between two discs is by metal connectors, and that too, ball type joint, as it is in our shoulder, ball type joint is there. So that ball type joint can allow the one disc with reference to other disc to vary its position and to take the least tension position. So it is connected by ball type joint. So there is a metal connection between two discs. So there are many discs, and between all the discs there is a metal connection. So now what happens is that after all, a conductor is there at the bottom because it is suspending, high voltage conductor. At the top is a cross arm which is grounded, cross arm of the transmission tower. So it forms the capacitance. So many discs in series means many capacitors are in series. And each capacitor has got its own capacitance. But all these capacitors are not equal. If there are 6 number of discs connected, then the voltage per disc is not total voltage divided by 6. This is because there is a stray capacitance also. There is a capacitance between a metal part which is not at 0 voltage. You see, the metal part between first two discs near the high voltage conductor is not at 0 voltage. So that and ground the tower, there will be a capacitance formed. That is a stray capacitance. And when there is a stray capacitance, current will pass through it. So you can just imagine that the current will pass from tower. That current is just a leakage current. Earth fault does not occur because it is in milliamperes. It is negligible current, but the current is there from high voltage conductor. It passes through first disc. Then the same current does not pass through second disc. Part of it goes to the stray capacitance. Remnant goes to the second capacitance. Then from second to third also same thing happens. So like that, as you go further and further, the current flowing through the suspension insulator, the current flowing through the lowest insulator disk is maximum, and current flowing through the highest disk, that is near the earth, is minimum. And because the capacitance is the same, XC is the same, XC is the same, IXC will vary and IXC will slowly go down. It will be in the descending order. Highest stress will be near the conductor, near the high voltage conductor, and lowest stress will be near the ground. Now you see what is the trouble? The trouble is, because of this uneven voltage distribution, we need higher number of insulators than in case of the uniform distribution. But uniform distribution is not there naturally. Therefore, we need higher number of insulators. And therefore, the cost of insulation increases, the cost of transmission increases. And therefore, to study this uneven voltage distribution is very interesting. So, with that, I have told about this, yet I will repeat that what is the motivation? Motivation is voltage distribution over different discs is not uniform because of stray capacitance, and this non-uniformity necessitates more number of discs to be provided in the string than in case of uniform distribution. This means that the cost of line insulator increases. No doubt it is not so that that there is people have not tried to make this uh, capacitance uniform. Line stray capacitance will be there, you can't avoid it. But yet with the presence of that, the capacitance across each disk can be made more or less even by different techniques. So one of the techniques is grading the ring, grading the disk. That means don't use the same capacitance for the disk. And another is the guard ring. Guard ring is the cheapest solution and most easy solution, technically most feasible solution. It does not give exact uniformity, but more or less nearer to uniformity it will give. Therefore, people use guard ring. You might have seen that there is a ring near the high voltage, ring connected to the high voltage conductor. That ring is trying to equalize the voltage across the different suspension insulators. With that motivation, what is our objective? The objective is to study and observe the effect of stray capacitance on the non-uniformity of voltage distribution over string of suspension insulator, and then with reference to that, to find out the string efficiency. String efficiency means what? The uh, total voltage that is available. Say for 132 kV line, 132 by root 3 will be the voltage across the string, because 132 kV is line voltage, 132 by root 3 will be the phase line to neutral. So 132 by root 3 divided by n times the, that is number of discs times the number of discs times the highest voltage available, that is the voltage across the lowest disk. So that gives me the string efficiency. String efficiency, if you go for 220 kV insulator, it is very bad. It is of the order of 22 or 25%. So we should try to bring it to as near to 100 as possible. 100 is just not possible, but you can try to bring as near to 100 as possible. And for doing that, you have to find out the, if not full, the partial remedy to that. So symbolically, it is like this because after all, the porcelain is a capacitor, and air between the metal part and grounded tower is also a capacitor. So C, these three species are those porcelain mutual capacitors, shunt capacitances of the porcelain. C1 and C1 are the, because distance is the same, these two capacitance also remain the same, C1 and C1 are the stray capacitances. Value of C1 is such that the current passing I5 is very low with reference to I3. So there is not much difference between I3 and I2. But I2 is certainly less than I3 because of leakage of I5. And I1 is certainly less than I2 because of leakage at I4. Therefore, if you really measure the voltage across disks, V1, V2, V3 across 3 disks, total voltage V is obviously line voltage divided by root 3. But V1 is not equal to V2 is not equal to V3, or V1 equal to V2 is equal to V3 is equal to V by 3 is not correct. V3 is highest, V2 is medium, and V1 is the lowest. And now, because of this, it is quite possible that if V3 is so high that the shunt capacitance C cannot withstand it and it will break down, then the total voltage will be stressed on two other capacitances. Obviously, two capacitances cannot withstand that stress, and then the whole insulator string will fail. Right. Therefore, to avoid that, what all you can do is, rather than using 3 disc, use 4 disc. You will have to use 4th disc, extra disc, so that the failure of insulator does not occur. I mean, this is what is really happening in field. So figure understanding is very clear from this figure, right? What is V3 or what is I3? I3 is equal to V3 omega C and I2 is equal to V2 omega C. I5, what is I5? I5 is between V1 and V2 because I5 is going to ground. So it is V1 plus V2 j omega C1. Right, it is C1. So if you use these relations, you see relations of current and voltages, you will find that V3 will be higher than V2 and it will be higher than V1. And this is because of stray capacitance and string efficiency is total voltage divided by 3 into V3. V3 means the highest voltage that is available. So because of stray capacitance, the problem comes because, right? And what is the value of V3? What is the value of V2? What is the value of V1? You can calculate. You can certainly calculate if you know the value of stray capacitance C1, right? If you can calculate that value, or if you can measure that value, then and shunt capacitance the manufacturer is selling to you. Manufacturer of insulator will tell you. So you know all these things and you know at what voltage you are going to use the line. You can always calculate everything, right? But calculation does not mean that it will ease your problem. Problem is the same. V3 is highest. That is the conductor near, I mean the insulator near the high voltage conductor is stressed the most. So there are 3 remedies. The first remedy is you reduce the stray capacitance to such a low value that the difference between V3 and V2, V3 is more than V2, but difference between V3 and V2 is negligibly small. For doing that, you will have to increase the distance between the string and the earth tower. And for doing that, you have to increase the length of the cross arm. So C1 is same, but I5 will reduce, right? That is the advantage. But then if you use a very long cross arm, right? If you use a very long cross arm, then the cross arm is very costly, and it uh, and there are many towers in the line for 100-kilometer long line, because for 1 kilometer usually 3 towers are there. So the line becomes costly. So that solution is not much feasible. Second solution is by grading the insulators. So, Bharti, नहीं था. हाँ हाँ जमी लो. So our problem is that the capacitor C are there, right? Now the lowest capacitor is stressed with the highest voltage. So the second uh, solution that is given is you can grade the insulators. How you can grade? You keep the value of C such that I2 into XC becomes I3 into XC at the lower part. So C cannot be C. It will be C1, C2, C3. So when you grade the capacitances, it will be C1, C1 and C2. Right. So that I3 into XC2 is equal to I2 into XC1 is equal to I1 into XC. These three voltages are equal. I mean, these three voltages are equal. I4, I5 are there. MC, the shunt capacitance is yet passing. You can't help it, right? But we are changing the value of the capacitor. But now you see, every now and then you will have to remember that C is the first capacitor near ground and C2 is near the earth for all towers. And this is 3 insulators I am showing. For 400 kV line, there are 22 insulator discs. So how to remember this? It becomes very inconvenient, infeasible for line staff to remember this. Therefore, this solution is not feasible. Solution of grading the insulators is not possible. So what is feasible is use of guard ring. Use a guard ring. What is the meaning of guard ring? How you will use the guard ring? This is just the value of what should be the value of C1 and what should be the value of C2 to make the uh, voltages V1, V2, V3 equal. That is shown for grading. But this solution is useless because this is not used. So what we do, we use a guarding. Guarding means there is a circular ring connected. Circular I cannot show here in the figure, but if you see that ring is continuously circular. It's a ring like thing, and it is connected with the lowest conductor. High voltage line. It is connected with the high voltage line. So what happens? There is mutual capacitance C, but there is one more capacitance C1 because air is there. So between guard ring and first point A, there is a capacitance. Between guard ring and second point B, there is a capacitance. MC, the stray capacitances are there, right? I1, I2, I3, the current passing through mutual capacitances are also there. Now, what I have to do? I have to do only one thing, because if you apply Kirchhoff's law at point A, I3 is equal to, sorry, I3 plus I7 is equal to I2 plus I5. That is my equation. I repeat, I3 plus I7 is equal to I2 plus I5. Now what all I have to do, I want to make I3 equal to I2. If I want to make I3 equal to I2, I have to make I7 equal to I5. So somehow you design your guarding in such a way that I7 equal to I5. So I3 plus I7 is equal to I5 plus I2. So in that, if I7 is equal to I5, then obviously I3 will be equal to I2. And if I3 is equal to I2, then the voltages V dash and V dash will be equal. So all the three voltages are divided into three equal components. You see, thereby you solve the problem, your string efficiency becomes 100%. So this is how you can equalize the value of the voltage. And to equalize the value of the voltage in 66 kV insulator, not very difficult. When you go to 220 kV and 460, 765 kV and all, 1200 kV, then the problems start, you see, right? For doing the experiment in the laboratory, because you see, this is, we are talking in the field, 132 kV, 765 kV. You cannot have 132 kV in the laboratory. So what we have done in the laboratory, we have used the simple 230 volt AC supply. And that also we are not giving 230, because if somebody will touch, then he may get a shock. So we are reducing 230 to 24 volt. Just very nominal voltage. So even if you touch, nothing happens, right? So 230 by 24, 250 milliampere transformer, because current is not a problem. Current, no high current is passing. So very small transformer we are using. So we are giving 24 volt on that side. And there are three discs. Therefore, we want 8 volt across each. Now, disk means capacitance. Capacitance means we purchase capacitance from market. Capacitors are available. Paper capacitors are available in the market. Different types of capacitors are available in the market. So we purchase capacitor of 0.1 microfarad each, right? We purchase a capacitor of 0.01 microfarad also, 0.03 also, 0.02 also, 0.005 also. Then as a mutual, stray capacitance, it will be say 10% of mutual capacitance. So we purchase 0.01, 0.02, 0.03. That means it can be 10%, 20% or 30%. The cross arm will be maybe smaller or longer. So you can have different readings. That means for longer cross arm, the voltage distribution is more nearer to equality, that you can check up by this thing, right? So this simple thing, the simple way of correcting the these things. You see, however, arrived at these values, C1 is equal to 2mc. I know C1 is equal to 2mc. Let me see. C1 is equal to 2mc, right? Because what is mc I5? What is I5? I5 is equal to j omega V dash plus V dash. That is 2 V dash mc. So 2 is there. 2 mc is there. So if C1 is equal to 2 mc, then I7 will be equal to I5. So that is what I do. C1 equal to mc. C1 equal to 2 mc and C2 is equal to mc by 2. And accordingly, I adjust the values. And I purchase the capacitors from the market. And I prepare a board like this. A small board I can prepare in the laboratory. Very small board. Like a switchboard in our house, right? If you do this, then you connect the circuitry like this. This is the circuitry for guard ring. 0.02 is connected in parallel with 0.1 and 0.05 is connected in parallel with 2. That is connected is the second junction. And I want to measure V1, V2, V3. And I want to see to it that V1 equal to V2 equal to V3. So if you take readings, V1, V2 and V3 will be more or less equal. They may not be equal because you see the material that you are purchasing from the market. He says that my capacitor is 0.005, but it may be 0.0055 or 0.0052. There may be some variation in the value. So exact equality may not be there, but V1, V2, V3 will be more or less equal if you try this. Yes, we are working on a very small voltage and capacitors are also small. They are not just for 24 volt or 30 volt, 50 volt capacitors. So cost is nothing, cost is negligible. But the principle that we are equating the voltage, that is conveyed. You see, unequal voltage distribution means there is nothing like guarding or grading ring. You can see how unequal grading is there. Same setup. And in the same setup, if you grade value of C1, C2 and C3, that is C1, all are same. I'm not keeping same. First capacitor 0.11, second 0.11 and third 0.13. You will yet get V1 equal to V2 equal to V3. But as I told you, every time you will have to remember that 0.11 should be at the center, 0.13 should be lower, 0.1 at the upper side. For all poles, you will have to remember that. Line staff will have to remember that. It is not engineer who is doing the work, line staff is doing the work. And if line staff, instead of putting 0.13 downward, downmost and 0.1 uppermost, if he does exactly reverse, then the things will be exactly reverse, and uh, the line may, I mean the insulator may fail, right? So that should not be done. So that's why this grading of capacitor is not a feasible solution. So with this, my friend, the equality of voltages across the insulator string, which is a very useful uh, philosophy or useful understanding of electrical engineering. Huh? And many students also do not know this. They fail to answer this. I asked a question. You see, when there is a circuit breaker with double or, I mean, multiple contacts in series, two contacts in series is so often there. So often there are four contacts in series. But then the voltage across all four contacts is, because you see, in one phase it is not one uh, breakage. There are two breakages, three breakages. So then voltage distribution is uneven. And therefore, to design a circuit breaker for such a system becomes difficult to see. So this unequal voltage distribution is coming in a way at many places, not only in this suspension line insulator. In circuit breaker also it comes. In lightning arrestor also it comes. Right? Everywhere this unequal voltage distribution comes. So uh, having passed through this very important philosophy, I read a sentence as I usually read every time. Respect yourself. What we are doing, we don't like ourselves. If you don't like yourself, then you can like nobody. So respect yourself, love yourself. और सो ऐसा कहा करते हैं कि कभी कभी ऐसा करिए कि आप अपने पांव को टच करिए. चरण स्पर्श जिसको कहते हैं ना, चरण स्पर्श, you do of your own leg, then you will not find it very difficult to touch leg of somebody else, some saint or some other person, your teacher, your elderly friend, your father. You will not feel like that. So you love yourself, because there has never been a person like you, because you are you are unique, and therefore you must be loved. And if you know how to love yourself, then you will start loving complete everybody in the world. And if everybody loves each other, then there is no question of, I mean, there cannot be war between two countries, between two people, right? That is not possible if it happens. So keep this under your mind. And with this, I close, remembering adapt me, right? Because adapt me is giving you chance to learn things. So don't forget adapt me. Keep always adapt me in your mind, and share adapt me to as many people as possible. I want that lakhs of people, crores of people know what is adapt me. because we do not have a big advertising network. We do not have money to advertise. We want to reach to people through loving people. And we want to love people by teaching them at free cost. We are trying to teach to you the highest principles at no cost. So we spread love, and then by that we want to spread our name, Adopt Me. So please spread to your friends also the name of Adopt Me. With that, good day.